Yeah, there is. You can download all of them in Starfire. Yeah, if you go to the normal agenda. Agenda, just editor or slash get wider circulate. Buttons, all the presentations here. I know this is Okay, let's get starting. This is the Ipsecme working group, and we have blue sheets going around somewhere there, I assume. So I'm Tero Kivinen. I'm here with David, who's our co-chair. Paul Hoffman has stepped down from the chair. I don't know how many years you were Ipsecme chair.
My ex-co-chair just said 7.
All right. Anyway, so let's go to the next slide. All right, so this is the notewell, which you probably know well already. So go to the next slide. So we have a blue switch going around. We'd like to get some note takers. Any volunteers? Dan Harkins is standing up, right? For a note taker? Not? Anybody?
So Shannon was volunteered to do the Jabber and notes.
Okay, if you do the note taking, I can actually follow the Jabber also here, because if it becomes, if it's really needed, I don't know if we have it. Okay. So, any other note takers or Jabber strikes volunteering? All right, good. You do the Jabber then. Okay, then let's go to the next slide. We did change the agenda a bit because we organized this in order so that we put all the items that are either in current charter or already agreed in the mailing list that will be in the charter in the first, and then we will have a charter discussion and seeing what of the rest of the items might come there, or we might come back to the charter in the end of the, when we get to other items going through, depending on the time. But I wanted to put the charter discussion earlier so we actually have time to do it anyway, because I don't want to have wasting too much time on the items which then then run out of the time for the charter. So any other comments on agenda or modifications we want to make? It's very hard for me because I can't see the slides at all here. Okay, so I need to take it for the local copy of it. So the first presentation is then for the then we have it some but we have actually, let's go to the next slide, which is a summary of the changes for the charter, what we are going to do. So we are going to remove the opportunistic because that's already done. We are going to add new items. The DDoS is already there, so we don't need to do anything for that. We are going to add these items about the algorithm changes and the new algorithms and quantum resistance and TCP encapsulation. We have already, agreed on in the mailing list. There's still some new work that we haven't agreed on the mailing list, and it's something we have a presentation today, which is split DNS, and then do we need to add something about young models? We have several, but there hasn't been any work on those and any others. So, but this is the summary. We will go through this when we get to the actual charter text and so on. So the next one I think is then we get to the DDoS protection. So, Joab?
Hi, I believe I sent a single slide. Yeah, there it is. So we had the working group last call. It ended early last month. We made some changes based on comments by Dave and by Paul Wouters. Merged all of them into version 07. There was one suggestion to split out the puzzle from the rest of the document. There was a thread on the list. There wasn't consensus to split the document, so we didn't. And I'm not sure if this requires an extra working group last call or that we can progress this, but I'll leave that up to the chairs.
I'm more than happy to progress the document as is.
Me too.
So with that, send us a Shepherd write-up for the document.
Me?
Yes.
Shepherd my own document?
No, we'll shepherd it. You write it.
All right. I knew that was possible.
So next we have me. Tiro.
So this is very quick update of the 4307 bis. Go to the next slide. Oops.
Oop. Sorry.
Okay, so what it is, this is the algorithms for IC version 2 only. We have a separate document for the Ipsecme, which we are also going to update at the same time, trying to get them aligned and so on. We are going to be deprecating lots of old algorithms. There is still DES and so on in there because we haven't updated this for a long time. We added some text about why we do this, and then we added this IoT algorithm stuff. And then there's a completely new thing that came up because this is the IANA register cleanup. Go to the next slide. So what we have done since last IETF, there is no changes in encryption algorithms, PRFs, or integrity algorithms, diffie-Hellman groups, RSA key lengths. All of those are still the same. Authentication methods, we added the shared key integrity code as must because that was already there in a RFC 72096. In digital hashes, signature hash functions and authentication methods, we do some more changes, which I have more in the next slides. So go forward. So here we added the shared key message out the internet code. It's just, to record that it's a must, and it's already must in a document, but we just wanted to copy it also here. Go to the next one. And here we did lots of changes. Because this is the digital signature OIDs. We wanted to say that, everything with this is a new method of doing digital signature, so there's no point of having anything with SHA-1 here, because nobody has implemented this. So let's say SHA-1 must not for everything, because we kept in SHA-1 in so much other places because it's still used. People have implemented that using it. Nobody's using here SHA-1, so let's say must not everything, and put the must on for the SHA-256 with RSA-PSS. And then I think the next one is, okay, I have the one more slide for what is signature algorithm, which I forgot. Okay, so that's the changes for the crypto algorithms. Then there's this completely new thing that came up. We have this, IANA registry, which has our crypto algorithms, and there's 3 of 6 algorithms. It has funny names, meaning not aligning with everything else. We have a ASGCM algorithm, which doesn't have the anchor underscore beginning, and they are using spaces, and they are using with 8 octet, ICV and so on. And, they cannot be used as identifiers in the code, and some code implementers has been complaining this several times. And go to the next slide. So the proposal is to rename them all to be aligned with all the other things. The reason I'm bringing it up here is that when I'm the IANA expert for this registry, so I could have probably do this just by doing this, but the IANA usually complain, say, oh, show me the RFC where it changed this and so on and so on. And I try to say that, okay, this is not a real technical change, this is just fixing typos and so on. We could do it, but they're more happy if you have a document, because that actually clearly points out that the working group is. And because we already have a working group document that is going to be doing about the same thing, which are also going to be referring to these. So that's why I was thinking about it, a good idea to add it here in IANA consideration section and say we rename these, and by the way, in the tables we use the new names. Do I have the one more slide? Yeah, I did. That's why I was okay here. So, any comments on that?
Yes, after you do that, what does the IANA registry show as the reference for this algorithm?
I think it keeps a reference in the same document that it used to be.
Okay, in that case, that document talks about a different string altogether.
Yeah, that's true. But I think most of the people will understand the difference there.
The people in this room will understand. Not sure all the people who implement IPsec will.
Yeah.
You can file an errata. Paul, Paul, can you go 2 slides back? Maybe 3? Actually, 1 forward.
Oh, I did have the slide.
Actually, it doesn't matter, actually. We're talking about the AES GCM versions. We have 3 versions with different truncations. And there have been some attacks in the past, and there's some rumors of attacks being released soon that further attacks these shortened versions. While we're doing this document, can we actually make them maybe should not? Or maybe downgrade them a bit?
Go a couple of slides forward. There's backup slides. Forward.
Is it already doing that?
So I have the, this is what.
Oh, we already did that.
This is what we have.
I rest my case.
So. Yes. All right. So yeah, this question is very good. I don't know actually what we are going to be putting in. We could actually probably put the 2 RFCs in the reference column also, putting this and the other one. I actually have talked with IANA about that. But that would be the same problem even if I would do that without working groups. But I think it would be a better idea to have it in the working group, and yeah. All right. Okay. Anything else? No? Okay.
So next up, 7321 BIS.
Or do you have some?
So now, Tara, with your chair hat on, are you going to move this to last call?
You are the shepherd. You should comment on that.
Do we believe the document is ready? I feel it is.
We need to modify the IANA section. We need to add that. And so there's going to be one.
So Daniel Migo Eriksson, I just have one question. Within the document, do we talk about ENC AES GCM, or do we mention AES GCM as on the table then? And then at the end we specify that's
Currently in the text we actually, currently in the tables we actually use the exactly same name what is used in the registry. And that's why I was saying that, okay, if you're ever going to change the net registry, it would be better to change it before we actually use it in this table. So
okay.
Doing it in this file, and then also do it in the 7321 bis also in that document also. So both of them are going to be using the same new IANA names, which are going to be used. But we have to talk, I have to talk with IANA about this also, what to be references. That's such a very good point that I need to talk about. But so we need one more review of this document, version of this document, and probably your document to change the names and change put the IANA consider section there.
Any other comments?
Hi, Tira. I'm just wondering, we don't have any must algorithms here. There's one must minus and a bunch of shoulds.
Yes, and that's this is a bit different because this is IC version 2. So this is only protecting a very limited amount of data that we are transmitting. We had two musts before this, triple best and ASCBC. And people have been saying the ASCBC is not something that we should actually move to the use then ASGCM or CCM or combined mode ciphers anymore. The problem with why don't we put the ASGCM as a must is that because it's using completely different method of encoding the IC version 2 crypto payload, and there's lots of implementations, or there's some implementations who don't support that at all. So we actually think that the next must is probably going to be Chacha 20.1305 at one point, but it's completely new, so we don't want to put it now as a or more than should. So this is transition, and we expect to make a new version of this document in a couple of years, 3 years or something like that. We don't hope. Let's hope that it doesn't take 10 years like it did now.
So in other words, you don't want to make ASGCM should plus because you're thinking it won't become a must, is that?
Yeah, I don't expect that. I expected it going to be the Chacha 20 to be the must plus, the must.
Okay, so I don't know if this is of a concern to the IETF, but if you take away ASCBC and Chacha is the only must, then you don't have any algorithms recommended, by the U.S. government. So again, I know that's not the, IETF's mission, but you might just consider that.
Yeah, so you are saying that the CBC should still say must, not must minus.
I think it would be nice to have one that's acceptable to us, and Chacha's not going to do it.
All right, so yeah, so that's a very good point. If we ever going to, in the next revision where we are going to change the ASCBC, then we are probably going to have to think about that. What's going to be the status of that then?
Paul Hoffman, actually responding to Sheila. No algorithms that the US government currently supports. You can change your list of supported algorithms, as can we. If the IETF chooses to go to some algorithms that you're not so fond with, you can be out of line with us, or you can be in line with us. And I say this because you had a Camellia one on your IETF. National government algorithms are national government algorithms. And the IETF makes choices for many reasons, but not doing it because the US government hasn't done something has not been in favor for decades. So if this working group goes to something that the US government isn't currently doing, you'll have plenty of warning on that. And that's up to you. It really is not incumbent on us to try to keep a particular national government happy.
Why I pointed it out.
Right. Yeah.
Go stronger than that.
Right. So that's why I think that must minus is actually very appropriate here. Instead of us already going away from it, we are giving folks plenty of warning that this may not be something that they want to do in the future.
I think the must, you're on, Sheffer. I think the must minus actually creates confusion more than anything else. If in the next 3-4 years someone wants to implement IETF from scratch, I think there should be a must. Whether the US government or some other government likes it or not, that's immaterial. But I think there should be some very clear direction for implementers.
So you are saying we should keep the ASCBC as must, remove
Yes.
the must minus.
Yes, with a note
Okay,
or whatever. but
Let's get
yes.
a hum from here. Who think that we should keep ASCBC as a must, and the other option is going to be changing it to must minus as we have now? If you think it should say must, hum now. If you think it should be must minus, hum now. I think there was a little bit favor of keeping it as must. So I think that would be something that we do at the next revision.
Tommy Polly Apple, just to clarify, so if I am an implementer and I do see a must minus, it still is a must for now. And if I read the definition of must minus, it just means in the future, this may change. But I think it's still clear from an implementer's perspective, I still do it now. So I think that's why it's okay.
All right. Come here.
Yes,
Just additional comment.
last comment.
But if we never go to minus, then we will never go to should because we need a smooth transition. So it's
It's fine to have two musts, one
Yeah.
must and another must minus.
Thank you. So next we have up RFC 7321 BIS.
okay. So, well, the goals are the same as with IETF, but except that it's ESP and AH. So next slide.
Oops.
So
Sorry.
in the beginning, we wanted to consider that crypto not mentioned in the slides would be remaining May, but we found out that there's little documentation on that, so we provided all the algorithm available on the INM page. So next slide. So here is what we thought about encryption. So that's why we have some very old algorithms. So I guess everyone agree with this? No.
First part of that. I think page 3, one of 3 out of 3.
So, next slide. So, well, I think we can just ask if you have any comment on.
So here we're leaving the AES-GCM smaller truncations to may. In the other document, were they may or were they should not? And if so, can we please make them the same? Because I don't
Yeah,
think
yeah.
they should be different.
Yeah, my idea was of concentrating on 4307Bs first, and thinking about the ciphers there, and then when we then copy it mostly here. This is not yet aligned with that one, but it's something that we want to probably do mostly. There is going to be differences. For example, here the AES-GCM is going to be must because it's important for the fast hardware crypto and so on. But it's not important in IKE because IKE, we don't transport. We could transport in total of a couple of kilobytes of data, so GCM doesn't really buy us anything there. There is some of these things that we need to modify. For example, the research ones that are actually not for IPsec use, so they are not made. They are actually must not, and there's same thing in later cases.
So this is not the last version. So next slide. Any comment? Maybe Shasha, should we move that a little bit?
I think we had it stood in other documents, so we probably have the same here.
So
The issue with Chacha is that, as far as I know, at least, there are currently no implementations out there. So once there are, yeah, it's a great algorithm, but it's hard to recommend something that we didn't do ourselves.
But when do we expect to have an implementation? I think it's soon.
I hope to do it next year, but
Oh, next year.
Tommy Polly Apple. Yeah, we hope to do it sometime in the next year as well. Also, just regarding the shorter GCM, in the other draft, they are mentioned in the text as may, but they are not in the table. So,
Yeah.
right. But they're actually specifically mentioned in the text as well as may. So this is consistent, at least.
Paul Hoffman, go back a slide. You don't define May plus in the document.
No.
Which one is it?
It's Chacha, Chacha.
Oh, yeah, May.
It's
That's why actually that's why actually was pointed out it should in the other document.
You're going to have a really hard time coming up with a sensible definition for May plus.
okay. So next slide. So authentication. And we also hope that this document is going to be a baseline for next version, so we don't have to specify the whole list, but we had to do it once. I mean, so must not will not be repeated in all the other documents. So anything you...
yeah, Jovnir, I'd like to mention that in the previous document and an earlier version of this draft, we had listed some algorithms that are from the IKV1 registry, and so they're not really negotiable with IKV2, and we chose this time to just ignore them as if they never existed, and this group might think differently.
Another thing is that the last one is going to be must not.
Well, 160, yeah, untruncated.
So those last two are not for IPsec, as you can see from the RFC number. They are for, I think it's iSCSI or something like that, and they want to use untruncated version because of, I don't know what reason, but they are not for use for an IPsec, so they are going to be must not in IPsec comes next.
Well, about this. So the one odd issue is you don't have it here. Maybe you have it on the next slide. It's the SHA-2 256 version. It's really tainted. Like, for instance, all of the current Android phones have a bad truncation because Linux did it wrong. And so I would really like to either add a note about that specific implementation in the document or somehow reference this. And so in our implementation, we have now basically push the preference down the list, so hopefully people won't select it. But maybe we can think about changing it from the must we have now to should not, and just go to SHA-2 512 instead. But I mean, it's one implementation, so I really don't want to change the document for one implementation. But it's all the Android phones.
Yeah, that's so maybe we should ask what people think about that. It's an implementation detail, but that is affecting pretty much.
So this is Deb Coley from NSA. Can you just like make them fix it?
No.
What? Surely things can be fixed.
Let me just explain. So it has been fixed, except if you're using the standard API in the Linux kernel, you get the wrong one. If you use the new API, you get the correct one. So there's just a bunch of code out there that just uses the existing old API. And they won't change the default. I told them, why don't you change the default to like the one that is specified? And they won't. So if you have more clout with the Linux people, please go.
Tim Winters, UNHIOL. So what we've been seeing when we test this is everybody does it the wrong way the first time around. They're all using the old Linux API, and it doesn't work. It's pretty bad. So in most cases, we explain it to them, and they go and fix it. But as we test it, we're finding these are it's pretty rampant, basically, is the unfortunate part of this story. I don't know what you guys want to do about upgrading it, but currently 256 almost never works out of the box on a Linux-based kernel or anything that's running over Linux.
So should I sum up that it matters that we consider the Linux implementation?
This is actually, I would propose that we actually put that in the text, explaining that there is reasons, because we have the rationale now, and one of the reasons to use a 512 is that, okay, there is
So
while
is-
we've
does
done
three-
this
Is 384
version,
broken too? So why don't you move to 384? Because we like 384 better. Okay, whatever. That's Sheila's argument, right?
Okay. So next slide. Compression. So anyone using compression? I should not say that.
Nobody wants to compress anything.
So, well, the idea is not to make compression mandatory into the implementations. Is that fine with everyone?
It's not a change. It's always
Okay, so, but we can standardize the change. Okay, right. So next slide. I think that's all. Thank you.
Next we have, anybody have comments on that? No? I wanted to put all of these both documents talking about algorithms back to back, so we can actually have it. We actually remember what the other one saying when we actually discussed. That's why I was moving this up. But next one is safe curves. You have one slide only again, I think.
Yeah, so last time I said that recently published, it was recent that time, version 01, and I think it's ready for working with last call, and I still think so.
Yeah, I think it should be very ready for the last call, so we should probably start it very quickly after that, I think.
Yeah, we can start it after this meeting.
Yeah.
Okay.
Then TCP NCAPs.
All right, I'm Tommy Pauly. Next slide. Anyway, so since the last meeting for TCP encapsulation, we have revved the draft a couple times, and we now have working group adoption for it. Can we go to the next slide? Sorry. Thanks. No worries. Yep. So we have draft IETF IPsec TCP encaps 01. And some of the major things that are in the working group version is that we moved all of the TLS support mentioning out into an appendix. So it still tells you how to do it if you want to use TLS to get through certain firewalls, but we're not going to pollute the main protocol, standards track protocol with a current fact of how we have to get around middle boxes. So we can also have a more generic way to do TCP encapsulation, which is good. And we also added a stream prefix. Thanks you all for that, to help the servers, the responders, identify these streams. And this is mainly a fact because we don't have a specific port, and we expect to be using this on streams that can be used potentially for other TCP traffic by servers. They need to be able to distinguish the IKE and IPsec traffic that's going through. So next slide. Right. So I wanted to reiterate these things because these were points of configuration that needed some clarification either on the list or in people's questions. So again, using TCP encapsulation is seen as a fallback. Generally, we expect people to try the UDP-based negotiation first and then fall back to TCP if things don't work. And this also applies for MOBIC. So when you're switching and you have a new interface come up, a new address, you can switch from TCP encapsulation to UDP and back. So still try UDP first. Also, again, there is no fixed port allocated for this. The draft does mention that port 4500 is already allocated. So if you're just doing TCP encapsulation to test or want a pure implementation, use 4500. That's great. We imagine people use 443 in practice, and that's probably what you're going to be doing if you're doing TLS specifically. All right, next slide. So in the stream prefix, so this was originally Ike v2, but then we decided that Ike v2 is too version specific, so I just made it Ike TCP. So it's just 6 bytes that you would put at the beginning of any stream. And so what that means is if you're just doing TCP encapsulation without anything else on top like TLS, it will just be the first thing that the initiator sends, after which you will have the Ike and ESP messages, which have the length then message format. If you are using TLS, the stream prefix would go within the TLS, so it's alongside the Ike and ESP messages. And so this can help you distinguish if you have other traffic coming in over TLS for your VPN server that this particular stream is doing this protocol. I have a question.
Sorry, Palvatus. So this is a prefix, and then you have the other regular 4-byte prefix to distinguish Ike from ESP?
So this is a prefix that's once for the entire lifetime of the connection. So this does not go for every packet. So essentially at the very beginning of the entire stream, you send these 6 bytes just to say, I'm not some other TLS traffic or some other TCP traffic. I'm doing Ike over TCP. Then you would have the length field, which is now a 16-bit length field. And then you would have the message prefix, which is either 0 for Ike traffic or the ESP SPI.
Okay.
Teddy Hogeborn, Nordisk Medieutveckling. Regarding the prefix, this is in-band signaling, and it's generally problematic. You've heard of the can't print on Tuesdays problem?
I do not hear.
It's when in some version of OpenOffice, when you printed on Tuesdays, it didn't work because the Unix file utility identified the PostScript file as something else because it had TUEN in it. So, I mean, this is in-band signaling, and any random TCP stream that happens to have these 6 bytes in them would be misidentified.
Right. So it mentions in the draft, as far as we are aware, this particular pattern is not valid TLS, is not a valid stream that we would be expecting to see on any of these servers. If anyone is aware of a problem with this, please.
You're essentially reserving these 6 bytes from any TCP stream. But you said earlier that you're going to use any port.
Right. And so, well, it is by configuration. So I think the idea is if you have an Ike responder that is specifically configured to be your VPN server, you have to make sure that this does not conflict with any of the other protocols that you are running on that particular server.
It just seems odd. Isn't this what port numbers is 4?
Yeah.
Yeah, that are given. So in normal case, of course, yes, you have a server has one port that is listening, and and the client knows that by default or by configuration, and he connects to that. Yeah. But the idea I assume here is that if somebody does some random, connection there, we from here we can see that okay, it's a Ike TCP, and we can verify and okay, yes, it seems to be okay. Let's process it this way. Instead of being, somebody just running, port scan on or whatever, these kind of things. So
I mean, this is a practical concerned, like the original version of the draft did not include this. You have brought up that, they have IKE or SSL VPN servers that already are receiving VPN or IKE traffic on these ports, and they need to be able to tell.
Yeah, I think the major reason for this is if you are ever going to be running this on over port, 80 or 443, just because that's the only port that goes through the, firewall, then you probably want to have this kind of thing on the other end to make sure that, by the way, yes, even in case you happen to end up, in, your web browser happen to use that also, the same port for your use that, that, okay, that's web traffic, that we can just ignore it instead of, try to parse it as IKE packet.
And if we are looking at the kind of like the pure version of I'm running on 4500, it's just a way of validating that this is legitimate IKE traffic.
Dan Harkins. The other port that goes through firewalls is DNS, and it also goes through most captive portals. So it'd be nice to use this to get around a captive portal. But if you put the stream prefix in there, then it'll allow them to trivially identify what you're doing and shut you down. So it might actually be better to not even have this.
Yeah, but I don't think we're trying
That's what
to
you think.
win
You would
on
say that,
level.
wouldn't you?
I think if someone wanted to block it, no matter how, unless we're actually doing encrypted TLS, which you can do, they could recognize the fact that, oh, we have a length, and then look, you have an IKE header. I don't think we can win that battle.
I still don't think it's a good idea, but if you want to keep it, you might want to say in the document that you shouldn't use this string in a middle box to identify this traffic. You should only look at the bytes if you are the actual endpoint server, which is
That would be very nice if middle boxes didn't look at things.
Yeah, but no, you could just note it.
Yeah,
That's what your stated purpose is. But if you have a prefix there, all people will go, ooh, look, and prefix I can use to identify this kind of traffic with, and maybe you should write that, don't use that.
Right, I'm not opposed to people being able to recognize that this is IKE over TCP traffic.
Yeah, but the 6 bytes does not guarantee this. That's the problem.
Okay.
You get misidentification.
Fair.
Palvata, so could we make this optional for those who care? I see Tero shaking no already.
I don't think so.
This is before we have any, kind of negotiation. We can't make it optional.
Brian Wise, I suppose if you want to make it less likely somebody will get it accidentally, you can just make it longer.
Right. So if we think a different
I don't know how many characters you'd need to get to some low probability.
The target for this string is actually the server. And the server is very likely to have both a VPN responder and some HTTPS server for maybe configuration, or the SSL VPN that's also terminated on the same box. So we want to tell them to have the server decide based on just reading 6 bytes whether this is IKE or whether this is going to be HTTPS at some point. That's really a low-cost way of getting it. Yeah, we could probably get it with 2 bytes as well. Anything that doesn't look like a client hello.
Right.
So, Palvata, so didn't they invent ALPN for that?
Oh, you have to read a lot more bytes for that. The extensions of the client hello to get there.
Right. And there's also, since we were doing this to be compatible with the pure TCP world, we don't want to have to rely on other encapsulating protocols. So anyway, so that's that. Any other comments are welcome. Okay, next slide. Yeah, so just other minor changes that affected a lot of the text, but not really the content. IKE v2 was replaced with IKE throughout because people thought it's better to not be version specific. I think that makes a lot of sense. If we have IKE v3, this should still work. And then we also modified the length field that will precede every message within the stream from 32 to 16 bits, because that aligns better with what some other current implementations over streams are doing. And so it makes it easier for people to parse. And it doesn't really make a difference either way. So as far as testing, Apple and Cisco are both working on implementations. We are currently ongoing of interop testing.
But once that's done, we'll send that out to the list and say how performance looks with all this running over TCP. If there's anyone else who has an implementation that would like to do interop, that would be great. So let us know on the list and we can arrange something. And then here are just some comments on, especially from like a client side, thoughts on how to practically do this. Because there are several different ways to kind of hack this into an existing implementation. So, one maybe ideal case for performance, but trickier for kernel code, is pushing all your TCP and TLS alongside your UDP encapsulation into the kernel, do it all in line. That is great, but often TLS in the kernel can be problematic. One thing that we found practical to do was just divert all the ESP packets that are coming out normally for UDP encapsulated traffic, divert those up like a ton interface into user space, and then strip off headers and send them back into a TCP TLS connection. And then lastly, you could also just divert kind of like the inner traffic from applications just over to a user space implementation of ESP that can run over TLS and TCP. So those are various options people have if they want to do implementations. All right, so yeah, please do send your comments on the latest version. Looks like the prefix is an interesting area, so any suggestions around that would be great, of how to maybe make the text more clear. And if you do have implementations, please interoperate with us. And then for the chairs, I don't know how much more revving we want to do on this, or we want to go for last call. That'll be it.
So I have a question. Do you think that it's ready for the last call?
Yeah, I think if we, if we're happy with the stream stuff, I don't think there's a lot more to do as far as the protocol goes. We haven't heard any more major issues, so I'm not sure what other things we would want to rev.
All right. The other question I have for the working group is how many of you have reviewed or read this document? Okay, what 4 or 5 hands? So that's not very many. But so I would hope to get paper. But actually, I assume those people are also thinking it should be ready for the working group last call, because a working group last call will get people to read it also. All right, we have to think about this. You have a question? No,
Thank you.
All right, so then we have this new topic. People have been saying that they are wanting to do this, but then we have decided that we are going to be working on this. But then I actually started to think about what should we do, because that's something that wasn't very clear. We have had a couple of digs and they were doing a little bit different, and I think we have to first make out the requirements what we are going to doing before we actually jump into the making any of the actual work. And that's why I was thinking about having this kind of requirements. And I don't want to write the requirements document, but I was writing a requirement slide set, so we can actually use these later and say that okay, which of these requirements we want and which ones we don't. So if we go to the next slide. So what this is about is that in Ipsecme 1, we had this design where the preset key is always mixed up with the encryption key also. So when you derive the encryption key, you put in the preset key there, which makes it quantum resistant in a way that even if you break the Diffie-Hellman, you still need to know the preset key to be able to read any traffic. There is certain issues with that. One of the issues is this, it's only used per shared secret authentication, which usually means very short passwords, which is, bad thing. But of course, when you are caring about quantum resistance, you of course use these very long, random strings as a shared secrets and not passwords. The other one is that, in main mode, when we try to do identity hiding, there is no identity hiding because you have to know the preset key before you can know the identity. so you can know from identity you can know the pre-shared key. So in that sense, you're actually in the chicken and egg problem that you don't know which key to decrypt this packet to know which key to use. So in practice, this was so that you could use only main mode shared secret with static IP. So your IP address the server has to know from the IP address who you are, so they can actually get your pre-shared key, so they can decrypt your packets to know who you are, which is a little bit this confusing. And this was this problem with this identity hiding property was the main reason why Ike version 2 didn't do this. We were discussing this, and then we said, okay, let's not use that. Let's use shared secret as an authentication information. Let's not tie into the crypto properties. But this one, of course, makes it so that Ike version 2 isn't quantum resistant in the same way that Ike version 1 is, which is some people have been saying, oh, we need to use Ike version 1 because it has these quantum resistant properties in case of. Of course, there is a lot of other issues with that, and it has been obsoleted now for more than 10 years. And Dan was showing me this for obsoleting Ike version 1, all right? No. So anyway, so that's why I was thinking about, okay, we should do something for that to fix it. So the Ike version 2 will be doing the same. Go to the next slide. I think we have there what we are going to do. So we need to define something for Ike version 2 or modify Ike version 2 so it will actually provide similar kind of limited protection against quantum computers. It doesn't really, because when you actually have a quantum computers that can break your signatures, also in real time, then you have other issues also. But this will solve the issue that, okay, if somebody saves your traffic now and you're using this quantum resistant system, they can't read your traffic. They can decrypt your, all the traffic that you have transmitted now when they actually be able to build the machine. So we are not really protecting traffic that is transmitted now. So that's why we want to have it very quickly out, so we can get the protection against this for a future of, so in 10, 20 years, they can't break it if they manage to make something. But there's one of the things we need to discuss is how much we're actually going to be protecting and what kind of things we are protecting. We go to the next slide. So one of the things is, do we actually protect only IPsec traffic? We think that in most of the cases, the important traffic we are sending is the IPsec traffic, IPsec traffic, the actual traffic in the TCP or whatever we are protecting, the VPN, your emails, whatever you are sending. That's the important thing that we must protect anyway. That's the main baseline. But then there's discussion of, do we actually need to protect also the IPsec packets? And then there is what to do with identity protection. This has different properties with identity protection, and depending on what we want to do that, it has different solutions. The next one is this pre-master, post-quantum computer pre-master key or whatever, what was PPK was, I don't remember the name of that. But anyway, let's say PPK. It's a shared secret used in that to protect this. How those are managed? If you have a one static shared secret and you never can change it, that's actually not going to be very good idea either. So you probably need to have some kind of ways to at least having multiple of those and changing those over time or something like that. And then the next question is, what about authentication? What happens if the quantum computers come there and you can actually break RSA in the real time? Can we actually do something also on that? So if you go to the next slide. So we start with the extent of protection. So IPsec. In minimal, we need to protect IPsec, right? So all the keys generated for ESP. This means that in Ike terms, we have to protect the keymat or the SKD from the PPK. We have to, use the PPK to derive those two keys. That doesn't change anything else. That's just the keymat and SKD. SKD is actually used to derive any of the other future keys. Keymat is derived from the SKD. So that's something we can do. So this means that even if the attacker can break the Diffie-Hellman, they don't see they can see the traffic inside the sent as Ike traffic tunnel, but they don't see any of the traffic going to IPsec tunnel because they can't know the key, even if they can, because they don't know what's going into the keymat or whatever calculation. But as I said, you need to make sure that nobody actually ever cracks into your machine and steals your secret, because then it doesn't help at all. Of course, it will help. So even if somebody managed to break in your machine and get the PPK, he still needs to break your own Diffie-Hellmans So he still needs a quantum computer. So it's, but then he can actually start attacking at those with the quantum computer after he has stolen your PPK. Okay, so the next slide. So the IKE is a little bit different. There is 4 different things in the IKE that we actually might want to protect. There's an identities, which gets the identity protection. There's traffic selectors, so what IP addresses and port numbers and so are used for this child essay. There's a configuration payloads, which actually usually leaks out your information about your identity if they are known, because they know you get set same IP address and so on. For other things, they're mostly stable. I mean, you get the DNS server, you get that kind of things. It's not very secret information. Then we have some kind of notification and extensions, and people are using their own proprietary extensions to do all kind of weird things that they might want to protect. So one way to protect IKE data too is to use PPK to derive the SK seed, which is the master, secret that is used to derive all the other keys. Or we just derive the authentication and encryption keys. Especially with the encryption keys, and actually with the authentication keys, we end up with the same chicken and egg problem in IKE version 1, meaning that we don't know the identity before we need to know the identity. So that is a little bit hard. There would be one of the ways that we could actually do this kind of partial IKE version 2 IKE protection, where we actually don't use the PPK to derive the SK seed or the authentication encryption keys, but we use it to derive the SKD, which is also used when we do the rekey. So the first IKE essay, when we create IKE essay in the beginning, it's going to be, if somebody can crack the Diffie-Hellman, they can read the traffic. But when you do rekey, that one already contains the PPK, which means that then after that, they can't read anything. So meaning if you want to have this kind of, really, that would allow, the implementation to have decide how much protection they want to have for IKE traffic. So if they are using, this password database dump protocol over IKE version 2, they might want to do, first rekey, and then to make sure that the Diffie-Hellman isn't enough to, just breaking Diffie-Hellman isn't enough to get this, protocol they are running. So they could protect after that. If they care about the traffic selectors, they make so that they create a IKE essay without the child essay in the beginning, then immediate rekey, and then create child essay. So then they get the traffic selectors protected. Same with the configuration payloads. I assume most of the people actually, or implementation, don't accept actually configuration payloads, anything else than out. So that might be something that they need to fix or modify. But it's actually currently already allowed. They are allowed to be used anywhere, so or information exchange, but nobody's using them, so nobody's implementing stuff for that. But that's one of the, it's already specified how to do that. That will not help with the ID, because identities, the problem is always, okay, what's going to be, we need to know the identity before we can know to get the PPK. So if we go to the next slide. So then is the identity protection. So there we have about 4 different levels. One is, no protection against anybody. So get rid of the identity protection completely. Move the identity to IKE essay init, where it's in clear, and then we can actually get the PPK from there. That's not a very good idea, but it's one of the options. And effectively, most of these things that actually, for example, this partial support, what they have doing in the current draft was actually doing a little bit that. They moved the PPK identity, I don't remember the name of that, but they moved this part of the identity in certain encrypted way into the, in the IKE essay init, and so it's in clear, so they can know it before they actually need to decrypt the packet. Then there's this second option is what we have now, meaning that we have a protection against passive attackers as long as they can't break the Diffie-Hellman, but no protection against active attackers. This is what we currently have. If you have an active attack against IKE version 2, your identity is going to be leaking. So that's no issue. Actually, this is the initiator's identity is leaking, which is usually the most important one. The server usually has already static IP address, so it's usually known already who the server is. If it's in the Google's IP address space, it probably is Google or some company they provide services. So then there is a third option is this protect against passive attackers, even if they can break the Diffie-Hellman. But then we have this chicken and egg problem. that chicken and egg problem. We don't know, we need to know the ID, but we need to know, to find out the PPK to decrypt the ID. We need to have need to know the ID. And so it's, but there is a thing that, for example, with the current draft does it has this kind of thing that, okay, we know this is the list of, PPKs. We go through all of them and do trial decryption stuff and so on. When we find something that matches, we can, know who the identity is. Yeah.
Dan Harkins. So you could probably get around this chicken and egg problem with Ike v1 resulted in like shared group PSKs for Ike, and then they did some hack like XAuth to do the username password thing. So people are already comfortable having like 2 PSKs. What you could do is you could have like the shared PSK is what you do. You kind of key wrap your identity and send it to the server, and that will allow him to find your PPK. And then each side mixes the PPK on each side. So
the Ike version 1 did it much worse because they actually, if you know the preset key, you can actually, impersonate the server, meaning that if you do XAuth and give your password there, I can claim to be the server and you send me your password in clear, and I can say, oh yeah, you are Dan, right. Okay, now I can go and log in as a Dan. So that's one of the things. Yes, we can do that similar kind of thing for identity only, which is one of the things that's actually saying there that one of the things we can do is use kind of pseudonyms. So the ID is encrypted somehow or coded somehow, which is so the server can users global search secret to just to decrypt the ID.
Right.
And actually clients doesn't need to know the ID. Client doesn't need to know about the key at all. They just get the random blob saying, okay, but it doesn't help here because the active attacker or possible, attacker who can, break the Diffie-Hellman can still, see that this is the same user. They can't see that who the user is, but they can see this is same, and this is same because the encryption is always same. But you can, of course, get rid of this by having a list of,
No, the encryption doesn't have to be the same. You could do something like SIV, and it takes it takes associated data. Your associated data could be the a nonce, or it could be the
then the problem is that all the clients needs to have this secret that is encrypted.
But that's what I'm saying, that people are already comfortable with having that sort of a deployment where there's
That's true, but actually one of the problems I see that is that then it's enough to hack into one of the phones having this configuration, get the key out from there, and then the identity protection is again lost.
Yeah.
So I mean, there is a trade-offs here. There's lots of trade-offs we can do, and I think there is several solutions we can do on different things, and they have a different trade-off how much denial of service attacks or whatever you can do for this. And then the last one is, can we actually make it so that we actually protect against passive and active attacks also? And I think in some cases we can actually do that kind of things also, but it has a certain case of trade-offs we want to, which I'm not sure we want to do. Go to the next slide. I think I have a bit more about it. Oh, then there's a PPK management. So what type of PPKs we have? This is one of the questions. Do we just have a one static that is always same, or do we have a list of PPKs like one-time password lists? Do we have actually a list of identities and PPKs? So we have a million of random identities, completely random identities, million of search secrets associated or PPKs associated with that, and identity associated with that. And client will just send, take the next one from the list. This is my random identity, and then he knows what his PPK is. Server will find this from the list that, okay, this is the random identity, here's the PPK, and this is the identity who is actually going to be. So this would actually solve this way. And then it would be also so that we don't, even if you break into one machine, one of the clients, you can only break identity protection for that client, not to everybody else using the same server. And then there's the next question is that, do we actually want to allow, hooking other out-of-band mechanism to share the PPKs, like the quantum key distribution? They had this mechanism of, getting, some kind of identifier for the random secret that they distributed over this secret, quantum key distribution method. So that's such, look like a one-time password thing. They have an identifier and they have password.
Brian Wise, Taro, this is really depressing. We've gone for years now saying we're trying to get away from pre-shared keys, and now we're saying, oh, the only thing that can solve our quantum problem is pre-shared keys.
Yes.
And now, this slide is really what really brings it all back. Why didn't we like pre-shared keys? Well, some management of them. I don't know if we really want to go back to that. The only possible thing to help there possibly is your last dash there. Well,
Yeah, let's
sure.
Let's get comment from the media code.
Hello, yeah.
Scott, I just kicked you. Can you come in? Oh, there you go.
Okay, can you hear me?
Yes.
Yeah, as for pre-shared keys, quite frankly, I see this as a short-term solution. Eventually, we'd want to replace our Diffie-Hellman, elliptic curve Diffie-Hellman with something that actually does propose quantum, being some sort of latest problem, Michaelis, elliptic curve isogeny. However, we're not ready for that. We are far away from actually being able to do something that we actually trust. So this is actually this PPK is a short-term answer for that to take us to that would be there to take us until we have something that we can trust.
Yeah, Scott, that's a very fair point. The only problem is, I think because of the management issues, we're really going to devolve realistically back to group pre-shared keys, which is so horrible. I just hate to think that we actually went back that far, and even if our temporary solution.
Yeah, actually, for this, I actually think that even the shared preset keys are actually fine, especially because it's or at least in for example protecting the identity. It's fine to have that kind of thing. I think it's actually one very good trade-off. So we can have, if we want to have a protection for identity, we have that with using the group preset key. In most of the cases, actually, I don't think we want to have a protection against the identity in for this kind of thing. So in that case, we can just use the preset key or PPK to just extra additional information that you can feed in. And however, and because it doesn't, even if you use it shared, it doesn't matter because it doesn't allow you to break anything from Paul's messages, even if you know the PP key, unless you have the quantum computer, or if you give it to NSA when 10 years later when they have the machines. That's actually one of the things, but it's a trade-off, and you can actually how you do that is an implementation issue and is your deployment issue. What kind of trade-off you are willing to do? But we want to provide now some kind of mechanism we want to which you can use. And then, yes, I agree that in the future, we are probably want to replace something with this quantum computer safe, but we don't have it. And next question is, can we actually use this same mechanism in that case? So the PPK is actually not going to be coming in a static table, but it's actually going to run some other protocol there to actually generate the PPK, and then we feed it in the same way that we do it now, which should still provide the quantum computer safe authentication and encryption in a future, even if then we just get rid of the PPK management with the protocol.
Brian Wise. So if that's the case, I think your last dash there about hooking into out-of-band methods for the long term is going to be a really important work item to go with this.
Yes, that's one of the things I would like to get. If people are know about how they think that the quantum safe computer stuff protocols are going to be. Is it going to be something that gives us some kind of shared secret that we have like in Diffie-Hellman? If it's going to be that, then we can use this. If it's going to be something different, then we probably can't use this. So we have to think about something else. But I hope it's something that it gives us some secret that is something that nobody can guess. It's going to be looking like Diffie-Hellman, but not doing Diffie-Hellman. Doing Diffie-Hellman in a way that is quantum computer safe. Giving out you exchange some packets and you get some random secret out that is shared in both ends.
Dan Hardens again. I don't want to jump the gun and start talking about solutions before requirements, as was admonished on the Jabber. But there is the ASN.1 symmetric key pack already defined. There's already blobs of bits you can throw around to send people symmetric keys, and those can be protected asymmetrically. And can use S extensions to pass them around when people enroll. And I mean, I don't think that that's a problem that we need to solve. Is
No,
what I'm saying.
agree
I think
on
there are other tools that
Yeah.
can be used to do
Yeah,
this
I
last
just
sub-bullet
want
point.
to
We don't
make
need
our
to do that.
protocol, what we make here is a protocol is going to be something that we can hook into this kind of mechanisms in the future.
So if you're passing a symmetric key around via an asymmetric mechanism, you still have a problem, right?
Yeah, you still have the quantum computer problem. Yes.
Right. So classically, you'd want to pass your pre-shared keys around by another mechanism, not an asymmetric one.
Yes.
Perhaps.
When we talk about solutions, but we can have
No, that's
a
right.
truck guarded by people with guns that
You could.
drives around.
You could, yeah. So distribution of the pre-shared keys is a problem.
Yes.
So you're not walking all the way back to your group keys, right? Because you still have your asymmetric, ephemeral Diffie-Hellman with it, right?
If you can do all that to avoid a free distribution of group key, that's great. I'm not sure.
Yeah, so you still have the problem. So you have to distribute the pre-shared keys, right? That'll be a problem. But you're combining that with an ephemeral Diffie-Hellman, elliptic curve Diffie-Hellman, whatever, right? Whatever you already have spec'd for that. And so this just adds to it and protects that.
Yeah, that's one of the things I actually wanted to also make sure that, for example, the original quantum key distribution draft, they tried to actually get rid of the Diffie-Hellman and use only this. And I said, no, let's keep the Diffie-Hellman, which means that we are at least as safe we are now. Even if your quantum key distribution always gives zeros, we are still at the same level of security than we have now. It doesn't break anything if it breaks, but it might give you more feedback, more information that you might be more secure.
Mark Orzechowski, CSG. I think there's room for both symmetric and asymmetric options here. There are going to be users for whom PPKs are suitable. They can use them. They can solve the key distribution problem. There are other users who would like asymmetric algorithms and to because they have a PKI that's working. There are various PQ asymmetric algorithms, yet they haven't stood the test of time yet. They haven't been properly evaluated, but you can put them in hybrid with classical Diffie-Hellman type algorithms to get a solution that looks something like Diffie-Hellman for agreeing a key exchange. It shouldn't be beyond our wit to come up with a protocol that can mesh the two.
All right. So then the next question I have is the authentication stuff, because I mean, in normal case, we keep the authentication same, but I was thinking about, can we actually make it a little bit better if we have this PPK? Because let's say you have a quantum computer who can break your RSA keys or something like that, but they can actually fake signatures only if they know what you are signing. So if you put something in there, like if you're using the PPK to map in the identity, they don't know what you are signing. So the signing part, some of the signing parts are still hidden from them. So they can't, fake the authentication even in that case, even if they can break your RSA. Of course, they can, break your, certificates and change and whatever, but, it still might offer some help.
But you can't guarantee that actually doing this gives them a new option to actually break the PPK.
No, I don't
now
think
you're producing an oracle for them.
Actually, yeah, but we are using PPK to hash in stuff anyway. We are using HMAC. If the way we put the PPK in is going to be HMAC, and it's going to be as a key or authentication key for data. So they have Oracle of that already. So they can actually.
So it's 1,000 graphics card and Oracle.
Yeah. It's going to be that way anyway. So if the PPK is not strong enough, it doesn't help anything. I mean, after break your Diffie-Hellman, they can see the all the other inputs, and so the only thing that is secret for them is the PPK, and it's very easy for them to and to see actually this, they also need to first break the Diffie-Hellman, then break the RSA, and then start attacking it. So it's a little bit too high. And that the last slide is about the implementation or next slide. So other requirements is something that we want to have this to be as small changes to IC version 2 so that the implementers actually implement it, because there's no point of having, wasting 10 years of designing this perfect protocol to do quantum computer safe, IC version 2, and then in 10 years we realize, okay, now it's ready. And by the way, quantum computers came out 5 years ago, and our traffic has been able to read for as long as possible now. We want to have something out now very quickly, so we can start saying, okay, now if you are caring about quantum safe, you just configure one shared secret in your config file, and that's it. And whatever you do the maintain it doesn't matter, but you are still supposedly being a little bit more safe for that. And it shouldn't open any new attacks, meaning that, for example, this service attacks in the IKSA init, and also other thing is that we want to make IKSA init to keep as small as possible to get away from the fragmentation issues and so on. So these are the things we want to have from the implementer's point of view.
Yeah, Clint McKay from NSA. So I just wanted to comment that. So I do have DoD customers that would use this extension if it were standardized, and it would decrease the desire to find an implementation that still has like version 1. But I'll say that the reason that these customers are interested really is the back traffic issue. It's not a concern that somebody's going to be breaking authentication in real time right now.
Paul Hoffman, a history lesson. We did design IKV2, and we went through all these discussions, and I believe that the most basic thing that we did in IKV2, which is important here, is we said, let's not worry about identity protection. One of the reasons we did that was because there were alternate proposals which gave you identity protection, and they were much harder. And we said, well, maybe it's okay that they're much harder. And then we started going down that path, and then we realized, oh, they're actually harder than those people thought, so we would have to make them even harder, and it became a rat hole.
Yeah.
I think for doing this, if we take that off the plate, I think that I think we have a much smaller problem space. And I also believe that if what we're trying to do is give a group of people who want this kind of protection something to do, something to use that they already sort of understand the wider parameters, pre-shared secrets. We already know that, because the people who are already caring about this are talking about going back to IKV1 with pre-shared secrets. We know that that is something that's known in the problem space. So going to your last slide of simplest, let's do simplest without redesigning IKV2.
Yeah. So you are saying we should keep the number 2, meaning
yes,
identity protection as we have now.
Yes.
We don't want to weaken it.
No,
We
there's
don't
no
want to
reason.
make it stronger.
Yes, there's no reason to weaken it, and because we've already got it. And simple would be simple, meaning things that people already know, and they might even have the code for in here. They just have to duplicate it into a different spot. So.
But I think as you showed that it's really easy to add a new notify payload in the IKE init that refers to ephemeral ID, and then you get basically the same thing anyway. So why not specify that?
It's one of the things. Actually, as I read, all of this what I showed now is something that I talked out yesterday and the day before that, because I still think that we have to think about these requirements. So actually, I think the next step is going to go and discuss this on the mailing list, because I think this was the first time people saw this, and there is people on the mailing list and so on who might be interested in all this. So I think the next steps are to start discussing about the requirements. What are the requirements? What do we want to have only, the second part, or do we actually want to have also some partial, pseudonym type of thing or something like that, which will allow to have identity protection and so on. And they actually might not be actually the same draft. It might actually be also, we have one part that says, okay, when you have a PPK, this is how you put it into the crypto. And this is, if you have a static PPK, that's it. So you take an identity, you get a PPK and put it that way. And then you have another draft that says, okay, this is how you, tell what the PPK ID, what the PPK is going to be, or it could be accessed with just a notify saying PPK identity, which is opaque blob of binary things that is, interpreted by the server and sent by the client. They already have to have a trust relationship. They know what is going to be in there. They can put whatever they want there. They can run their proprietary, or it can be just a 32-bit number telling what is the number of what is the secret key you are going to be using for your table. So something like that.
Tommy Polyapple. Yeah, I was actually going to say it feels like this should be maybe split up into two different things, that we should have just like the very simple, like, here's how you put a PPK into your key mat, and this is the way to do it. Because I think that's pretty clear. And if there are other places where we can, salt it in that don't add any complexity, then that's great. Yes, these other options to put stuff in the init are viable, but I think those could rat hole more. And so having like a separate.
Yeah. My proposal was to put the PPK ID identity payload into the auth. It would be the secondary, part of the identity. You still have an identity, and then you have this. And of course, you can use ID null if you don't want. If you want to have an identity protection, and PPK ID might be your complete identity with some kind of, impedance-independent formatting. But anyway, I think we are running out of time, so we probably need to finish this.
Okay, thanks. So next up we have charter. Let's bring those slides up. Now, let me just grab a new copy. Need to grab a copy.
See your slides.
Actually, let me get the PowerPoint version of it. In case we want to make any edits.
Okay, while he's use the mic. Okay, so the charter stuff, we had, the basic charter. We are not going to modify the stuff in the beginning. We are going to be adding a couple of new items we have been already discussed about, and then we have a text about those when we can find those. So what else? Oh, don't press. Okay. All right, so this is the current charter, what we have now for the beginning of it. And I think there is actually no changes in this part. So we can actually go to the next slide. And this is the current work items. The first item is denial of service. There was this, the first item was what was the one that we removed? Opportunistic encryption. Yes. Opportunistic draft. So that was removed because that's already done. So we added the next one is the denial of service attack protection, which is already going well and should be coming out very soon. And the next item is, I think, is new, which is that, okay, so we want to upgrade the, the cryptographic, mandatory to implement cryptographic. And I put it, we modified it so that it has both, for the 4307 and the 7321. So both of the ESP and IC version 2, because I think we want to keep them aligned and we want to revise those. And that this is something we probably want to revise in couple of years again, because especially when we see how the CHA 20 and Poly 1305 starts to be, get to the implementation. If it gets to implementation very quickly and we can see that it's working fine, then we might move it as mandatory to implement faster. And if we don't see any implementations, then probably we are not going to be changing anything. All right. So then they have a next new items that are the safe curves and EDDSA.
So the first one is
that's the next two out of two. Yeah. So there is this, the safe curves, and actually this doesn't talk about the EDDSA. So we should probably add an EDDSA, because that's one of the things we want to also probably do at one point. We don't have a draft for that, but I think that's something. Oh, you have a draft. That's true, actually, yeah. But anyway, so I think that's something that we can I think it's something we want to work also for that. And then there's this quantum resistance computing stuff, and having a little bit of history there. And then we have the UDP encapsulation. And this is something that we have already discussed on the list and agreed that we are going to be adding on the charter. So anybody has any comments about these items? AD has any comments about this? No?
I actually have a comment about the last paragraph. We've had it forever. It's sort of ceremonial text. I think it's time to remove it.
No. Oh.
Yeah, so I think the IESG and myself included in that are much happier to see that text, especially with how long PKICs lasted. Knowing that it's going to have to be refreshed and the group has to show enough energy each time it gets changed is a good thing.
Oh, goodness. Well, there's a lot of light in that, I feel like, so.
Kenny Patterson, speaking partly in my role as co-chair of CFRG. I think the post-quantum key exchange that you were discussing earlier is going to take a lot longer than December 2017 to reach a state of maturity.
No. The charter item isn't talking about the post-quantum computer protection. It's talking about resistance to quantum computers, especially about this PPK stuff. So we are talking only about the PPK, this kind of PPK, very limited resistance.
Sure, but if you're going to wrap up your working group,
no.
Well, I'm reading the text
yes,
in the last paragraph, right?
If we don't
you might be misaligned with the timing at which the post-quantum algorithms, which suddenly you're going to want to incorporate, are ready to use.
Then we recharter and add it to the charter, and then we change the timer. That's one of the things we actually. I think the 2017 is actually we should be ready with our current items before that, way before that.
So Paul Hoffman, I'm not getting the feeling that by December 2017 we're going to have any idea.
I agree.
Therefore, we should go. We should go fallow. We should. If that's the last thing. I mean, it seems like you're always finding more things.
Yeah.
But if that's the last, and when I say you, I mean previous me, since a lot of that stuff was there when I was there and when Yaron was there. But remember that you can actually start up a working group for a single item. So it doesn't have to be starting up IPsecMe again in 5 or 10 years when we have the post-quantum.
And
it could be for one thing, and it could be sort of like Kernel.
Yes, I was just pointing that out.
And so now you're going to have to think of like acronyms that have a Q in them and such like that for those sorts of but I would say that it's actually a good idea for you to try to shut down again, even though I failed repeatedly. It's still, I agree with Kathleen, it actually is a better goal.
Yeah, if you don't have any work items to do,
right,
then we should shut
and
down.
to give it a date to do it, because quite frankly, we've taken too long on the algorithm biz documents. If we had been more motivated, they would be done sooner, and we would be actually just on, do we want to do this new thing? Do we want to do this new thing? And when the room runs out of energy for new things, then you'll know.
Yeah.
Good luck.
And then we have a couple of items there that has been discussed in the list and has been presentations here. We are going to be having presentations, the split DNS and Young models, and then there's this implicit IV and so on. And we haven't agreed on those yet to add it to the charter. And I think we should now probably listen to presentations of those and then think about in the list and so on, whether it should be added or should we add it now or should we add them later. But it's something that we can probably continue, or we can come back depending on how much time we use after that. We can come after those presentations. But if people don't have any comments about I think this charter here is fine, then you can probably go and see the new work that might be getting added to the charter. So the next one is split DNS, Paul Waters. Yes, you can update it. That's fine.
It's going to take me a second to get your slide.
Okay, I'll just talk. Okay, so Paul Waters. So this is a draft that me and Tommy wrote. We were lacking some options to do specific DNS and DNSSEC configuration. This was added in IKV1 using the XAuth mode config things, and not all of that was actually brought into IKV2. So we wrote a draft up to add those things, which is appearing on the screen. Next. I guess you can't see it too well from the back, but this is just a configuration payload. There's a new CP payload internal domain. You can have one or more of them. The option can be empty, whereby you signify that you will accept any domain, or you can specify domains and say, well, I'm Paul from Red Hat, so I will only ask for you to give me some name server for redhat.com because I don't trust you for anything else. The server can reply with the payloads, so it will give you the already existing identifier for a name server IP address, v4 or v6, and the domain associated to it, and it can also be one or more domains. So this is, we thought, fairly straightforward, but Tero disagrees. Tero.
Yeah, Tero Kivinen for Insight Checker. Yeah, actually, I have one question about that. In a couple of cases, we have this place that if you send as many of requests, if you send two internal DNS domain requests, you can only get 2 back. Is this going to be that way? I think for IP addresses, I think we have, or it is going to be so that you actually, because here you have 2 requests, 2 in the request and 2 in the response. I was thinking about if it's actually going to be like that, or it's going to be so that you just send an empty internal DNS domain as a request saying that I want to have those, and then you get a list of back.
Right. They don't have to match. Yeah.
Okay. So it's going to be client asks for 1 or more. Actually, why would the client will propose whatever he has, and server send whatever he has.
Right, and then looking at how I currently actually implemented in our code, the server will promptly ignore everything the client said and just tell it what it's willing to serve anyway.
Tommy, Pauly, the way the draft explains it is, well, it should be that if the client says anything with DNS domain, that indicates that they do support it. If they send just one that's empty, the server can send as many domains as they want. If you do specify a specific domain like we have up here of other.com, the response can include other.com or as many like subdomains of that. It can make it more specific if it wants, but it cannot make it more general.
Right.
And if it does, the client should ignore it.
And while we're doing this, there's also the issue if you run a split domain, a split DNS view, and you have an internally signed and an externally signed domain with DNSSEC, then you also need to give the client a trust anchor. So next slide will tell you how to do that. We'll actually go to the next slide. Now moving back one. There we go. So there. Interesting. We don't put it in the CFG request. Is that actually correct? It should. That's incorrect, right? Yeah. So the client should also ask for an empty internal DNSSEC TA and then get an answer back. And that's basically and I've already updated here. It's a DS record in presentation format that's being sent back to the client.
I think it's actually very ugly to send that kind of strings there, but. I would rather actually use some, DNS record format or some other format than that kind of ASCII text.
Why? Because this can immediately be given off to your resolver that's running locally.
No, it's going to be given out to the local DNS server, second resolver API, which has the the keys and so on. Not everybody is actually using, especially the local resolver might not be, doing. If you have a local DNSSEC resolver, it might not be.
If you don't have a local DNSSEC resolver, there's nothing you can do with these trust anchors anyway, so you just ignore them.
No. If you have if you are a resolver that does the local DNSSEC resolving inside the library itself, then you have to give somehow the trust anchors to it, and you use
Yes, and
just
so,
an API.
so most of these read them from files. Like look at the various implementations we have. They read trust anchors from a file, and the way it's sort of specified now, it's all in presentation format.
Yeah, but I'm always a little bit worried when we have a big text of chunk, big text strings in middle of this kind of binary things.
You're not going to make them much smaller because they're either going to be a DNS key blob or a DS blob. Like
it's half the size because it's not in hex; it's binary. The DS record itself is not going to be in hex.
Yeah, and then all the clients will have to convert it to presentation format to give it to the DNS library.
Yeah. Then they actually check out what is in there and not just blindly trust it. And when you have the $includes the etc password in that file, and you give it to the the DNS library, which actually reads it in. No, but he was saying that we actually put it in the file and give that file to the resolver.
No. Sorry, I was saying currently the way DNS libraries accept trust anchors, whether it's the root key or any other locally configured trust key, is usually in a presentation format already, DNS presentation format. So I see no reason to come up with another format for us to use. And a binary format is going to be really ugly if you want to specify this in a configuration file for the server. So that's why we pick presentation format, which I do think is a reasonable choice.
Paul Hoffman, sorry, I haven't read the draft. Is this to give a new trust anchor or to actually specify the key? To give them the full trust anchor so they can use the public key, or just to point at which of the pre-configured keys they have?
No, this is a new key. So I connect to the Red Hat
So you can't use a
VPN.
DS, it has to be a DNS key.
No, actually, so that's why at first, actually, the current draft actually says DNS key, and we wanted to switch it to DS because it's a little smaller string. I asked the resolver people, and they said that you can actually give them a DS record, and they will do the insecure lookup to get the DNS key match.
Followed by
and then,
a lookup.
Yeah.
Okay, yeah. Okay, sorry. I'm sorry, and again, I apologize.
Yeah,
on
no,
that.
no. I
And in
specifically
fact, DS
asked the vendors if they could do this before I wanted to switch.
And DS is much, much more common than DNS key for trust anchors.
Right.
I say as the person who's become the trust anchor person at ICANN.
Yeah. Then the other question I have, I assume that all the DNS servers are supposed to respond to all of these internal domains. So you can't have one domain for responding to.
So we thought about should we make this a per domain thing, but that seemed to be a little over engineered. So we went back to like, well, you're on a VPN, you're on a choke point anyway, so you should run a DNS server that solves all of your internal domains.
All right, yeah.
And also, actually, the draft also has a note, for instance, to say that you cannot accept any IP address that isn't actually covered by a child SA. And if you got multiple child SAs and you want to reconfigure DNS server, you should wait until they create child SA for your that covers the DNS server's IP is up before you reconfigure your name server. So you can't put in like some rogue IP address and hope that you'll get like all the unprotected DNS traffic across the world. Okay, and the last slide just asked you to adopt it now. So Apple and LibreSwan did do an interrupt.
I think we're good.
Tommy, probably I will just say, I mean, part of the reason why we want this also, like, we've seen a bunch of like enterprise customers and internally at Apple ourselves, like people who historically do use split DNS, they're all staying on IPv1, and this is one of the major things holding them back from IPv2. So this would be awesome to get people to switch.
All right. So first question, how many people has actually read the draft? I don't think I need to ask the next question then. Which would have been, should we actually adopt this as the working group item, or should we add it to the charter? Actually, I can actually add that, yes. How many
Valerie
people
says that he has read the draft.
Oh, okay. So actually, I could actually ask you, how many people think that this is a problem that we should solve in Ipsecme, and meaning it is there is a real problem and there should be a work item for that in the charter. So if you think that this is something that people should work here, and the other question is you don't think that it's actually either the, we shouldn't work on it. So how many people have actually, let's make a hum. So hum if you think that this is something that we should work on here, hum now. And if you think that we shouldn't work on this, hum now. Okay, so there's a clear, seems to be clear, idea that we should put something about in the charter about the split DNS. We probably are going to be taking this draft as a working draft at some point, but we probably want to get at least a couple of more reviews. For example, I think the chair needs to read it first. Which is why I've been asking so many questions for you, because I haven't read the draft. And the formal chairs and so on. Okay, so moving along then. So we actually we probably talk with you and think about some text to put in the charter and put it in the charter update now. Okay, so next one was, I think it was implicit IV. Joab marked there.
Okay, this one I'm not going to finish in half a minute like the
You
previous
have more than
ones.
one slide?
Yeah.
And black slide, so no colored slide.
Oh, yeah. Okay, so this is about implicit initialization vector for counter-based ciphers in IPsec. Next slide. So why? Counter-based algorithms such as ASGCM, ASCCM, CHA-20 are becoming more popular. And unlike CBC-based algorithms, they do not benefit from unpredictable IVs, or rather, they're not vulnerable if the IVs are predictable the way CBC is. And most specifications recommend using something that guarantees you that the IVs be unique, and mostly they recommend just using a counter. There's also the possibility to use an LFSR, but yeah, just go use a counter. So next slide. So this is the ESP header showing the SPI, sequence number, and IV. Next. So this is a packet sequence number. Next. This is also a packet sequence number. And in fact, if you look at packet captures, these numbers are the same for each packet. So next. Okay, being engineers, the counters are going to be equal. And why repeat them? So we don't really need to repeat them. So if both sides agree, we can just omit the IV because it's implied by the packet, by the sequence number. IV is optional anyway, and that can save us a whole 8 bytes per packet, which is about. Yeah. So it's about 0.5% for large packets, a bit around 10% for small packets. So next slide. Now that comes the hard part, is how do we negotiate this? So we thought of several ideas. One was to add a new transform type, and we have encryption integrity, PFS, and ESN. Add another one that can be true or false. That has two problems. First, these four things, encryption, integrity, PFS, and DSN, are the only things that have only transform types that have ever been defined. So if we send a new transform type to any implementation, who knows what's going to happen. It might crash, it might not respond to us. And anyway, this requires that we double the, for BC, we have to double the numbers of proposals, because if a proposal contains a transform type that you don't recognize, just reject it. So the second idea was to add the new transform attribute. There's only one transform attribute currently defined, key length. Let's add another one that has the same issue that no new transform attribute has ever been defined. And we know from other protocols what happens when you, for the first time, add a new value to something that always had just a single value. So, and again, you'd have to double the number of transforms, of encryption transforms. So well, let's skip that one because that's the one we like. No. So another option was to use a notification to negotiate it. Well, first, using a notification to negotiate something is icky, and that's a technical term. On the other hand, adding a new notification that is unknown, that's pretty much a safe thing because that's all we ever had in all the extensions for Ike that we did. And then there was just make a new transform ID. So there's ASGCM_16. Let's add a new one, ASGCM_16_IIV. I mean, that kind of uses a lot of space in the registry, but then it's a 16-bit registry, so yeah, that looks like the preferred thing to do.
Tero Kivinen, Insight Seeker. Yeah, I think the first one is actually would be very bad adding the transfer type, not because of this new one, but because this implicit IV cannot be used with all ciphers. Meaning that you can't use it to the ASCBC, you can't use it, which means that it would have a very weird semantic saying, okay, this IIV actually applies to certain ciphers that is listed somewhere that you don't know where. It's really bad.
Well, we actually had an idea for doing implicit IV for CBC, but that was
okay.
Even more baroque than that.
Okay, so the next one is the new transform attribute. That would actually be working because then we could add it only to those that are actually using this. But I don't think it actually. I think the new transform ID is the best way because then we can actually define it. It's especially for those ciphers we know that this is safe, and we can very easily negotiate. So I think your proposal for having a new transfer ID is the best, and I'm all favor of that. The question is that okay. It always comes up with this one when this hasn't been the first time this is proposed. And I don't know if this is going to be last one, I don't know. But anyway, so usually the problem is that people say that, okay, IV is part of the, the crypto boundary of the sequence number is outside of the crypto boundary, and you have this FIP certified, crypto operation who generates the IV and generates this, and it's the IV generation done on the hardware and so on. It's sometimes, and the sequence numbers are not, and so on. So there is this always this, layer. People are complaining about this is, breaking the crypto boundaries, and we have to certify the whole IPsec, whole ESP. I think that's mostly it's not really that important because usually you have to certify the whole ESP anyway, or whole IPsec or whole IKE. You can't get actually, only the crypto library and not certifying the rest. So that's why I think, but of course the hardware issue is a little bit different because if the hardware is, generating that, and they might not actually be, in some cases where you have multiple CPUs or multiple hardware cores, they might actually have a different, IVs running in different speeds because they have, different partitions in the IV range or something like that. So that might be, so you might not be able to, but of course that's something that when we negotiate, you don't negotiate if you don't support.
Yeah, if your IPsec is such that if your crypto is such that you can't set the IV by in your own software, then
yeah. But I think these are something that you should probably put that down in the draft also, that makes sure that they are measured there. And also the crypto boundary issue is something that I know that is people going to be asking.
Yeah.
Tommy Polly Apple. Yes, I agree. First one's problematic. I kind of like the transform attribute, but I see where you're coming from for the transform ID, even though I find it gross to blow up the list like that. One question though, is there any reason if I supported the implicit IV and the other side supported it, not to use it? If you did the notification, one difference in behavior is that rather than having, to have multiple transforms to iterate, oh yeah, I support GCM without IV and with the implicit IV, etc. You have to choose, okay, which transform is it? As opposed to just saying, hey, I support doing implicit IVs, so if you also support it, just automatically switch anything that we choose that works with implicit IV to use that.
That would work.
Yeah, I'm just saying that it's a different behavior of notify. I'm not saying it's good, but yeah.
it's doing negotiation with notify. I send you a notify, and if you agree, then you send the notify back. That's people don't like that.
I think actually it has the same problem at the new transform type, meaning that because not all ciphers are able to use this. So in that case, you need to have somewhere some table or something telling, oh, if I have a notification saying IIV, I need to see that, oh, this cipher can support this, this and this and this don't. So you have to have this kind of, and there's a very easy way to, you know, and you get these mistakes that, okay, do the other end support it or not.
So I could imagine then kind of getting the same thing potentially if you did the transform attribute, having the attribute be I support IIV. And if the other side does not include that, then you know that they don't support it, but you could still end up choosing that transform without having to iterate both versions.
Yeah.
Paul about this. Yeah, I in fact actually also would prefer the transform attribute. If we could get some numbers now to see if how much would die if they see an unknown attribute, and pending that one, I would prefer to notify because the code for all those transforms and features within the transforms, mine is already ugly enough that I don't want to add another check on these features myself.
Well,
So
the thing, we have the experience of the TLS working group, and you always have the major browsers and OpenSSL and the 3 others that all do the version negotiation fine, and then you find the other 20 that you never heard about, and oh, this doesn't work anymore.
there's also right now some software out there that already has a giant transform ID list, and you're suggesting that they're going to basically double it.
No. I think there's about 3 or 4 ciphers that actually are going to be defined. ASGCM and what else?
And Camilo CCM and Chacha.
Are for 128, 56, and
So
maybe
we have
192 as well.
5.
Please don't double the registry.
Brian Wise, so let me just clarify. So the packet format would be, we would not be sending the IV, correct? We'd still be sending a sequence as opposed to the other way around.
It's really a 0-length IV.
Okay, so might I suggest that what we're doing, if you do the notify method, then you're adjusting the AEAD definition of the transform. Is that really acceptable? And is that a good precedent to be set?
Well, the nonce is still there. It's just implied, compressed. It's not, you don't have to send it implicitly. You're allowed to send it explicitly, but you're not required to.
Yeah.
So the argument, that's actually one of the reasons I think the transform IDs is because I think this is actually new cipher. It's an ASGCM with implicit, IV. It's a new cipher that gets input as a sequence number from the external body that is used to generate the nonce, and the sequence number is guaranteed to be unique.
Yes, but the ciphertext is going to be bit for bit the same.
Yeah, I'm saying that here by this is going to be more like a new cipher than having a mode in there, and one of the reasons why they lay out the IV is that as he was saying that in ESP payload, the IV part is actually optional. Sequence number is always there. That's mandatory to be there. We had a long discussion on that in the early days, saying, okay, what the best other end doesn't support replay prevention, or because the replay prevention is not mandatory. You don't have to implement it in the receiving end. You can actually accept packets with duplicate IP sequence numbers, but you always have to generate them with the sequence number. That was one of the things we make, that we simplify it so that you always have to generate. So the sequence number is mandatory there. So that's why it's leaving out the IV, not the sequence number, because IV is not mandatory, because there is ciphers that don't have IV.
Brian Wise, so on the doubling the cipher seats, I just wonder the motivation of this seems to be probably for small devices or dealing with small packets and so on. I don't really know, but that's how I would use it. I probably wouldn't be sending all the other transforms in that case, but I mean, I understand Paul's pain when he says please don't double them, but I'm just wondering if they would actually all be automatically put in the browsers or the normal use cases or not.
Well, browsers are not doing IPsec, but actually, TLS 1.3 does the same thing for all of these. Well, they only have these kind of cipher suites. Anyway. Okay, so last slide.
All right, so I think that's all for that. I think there's one more presentation that is a diet ESP, or we can talk about the. I think actually let's make a hum about this. Do we actually want to adopt this, and do we actually want to make this? So, how many people actually think this is work that we should be doing here? And the other question is that something that we don't want to work here. And of course, the details how we actually do this and define is up to the working group anyway, but this is something that we want to work. So if you think that we should be working on this working group, hum now. And if you think that this is something that we shouldn't be doing, hum now. Okay, I think that's very clear that we actually want to have it. Okay, how many people have actually read the draft? Oh, there's almost double to the previous one. Which isn't very much, but anyway. So I would actually like to get more reviews on that and also, but anyway, but okay, so that's something we should probably think about if we actually add it to the charter. We have to discuss about this a little bit more, because this is split the energy for a bit more, okay, the diet ESP, I think the next is that, which is about the same thing, but different.
No, because we are not using the IV as the sequence number. So, well, the purpose of diet ESP is to have an ESP that's matched the IoT requirements, which is reducing the networking overhead. So next slide. So, well, currently IoT only has DTLS 1.2, and it might be good for any web-based IoT applications, but it comes with a pretty huge overhead, which is 29 bytes. So, well, the standard ESP is 20, and so it's still better. But with diet ESP, we're trying to make it even more compressed, and the compression occurs regarding the use case we have. So next slide. So what we'd like to compress with diet ESP is almost everything except the payload data and the ICV. So the security in SPI, sequence number, padding, pad length, next header, this could be compressed, which means reduced to 0, up to 0. It's not necessarily 0. So overall, it makes the packets about 11.5 bytes smaller, given that the padding is not a fixed length. So next slide. So how diet ESP works? Well, it really compressed the header and the trailer. So it's a little bit, because we are already doing compression of the ESP. We have a ROC, we have 6-LoWPAN, but they are mostly focusing on compressing the ESP header. The main difference with diet ESP is that we will also take care of the trailer, which is the padding, pad length, and next header. Next slide. Well, I think that's what I said. So next slide. And one of the big advantage of a ROC is that ROC is a huge compressor and cannot be implemented in small devices. And with IP, we have this IETF negotiation, so we can definitely agree on parameters that are not changing. So we have some because, well, diet ESP is a combination of ESP and compression stuff. So we have some different discussions depending the community is involved in. So regarding the compression, the way we designed a diet ESP, the compression in diet ESP, is that we started from ROC and we said reuse all the ROC compressor, decompressor, but just initialize with some parameters that have been negotiated with IV2. And so well, it was a subset of the compressor. But then some people said, oh, but if you have a subset, then it's not anymore the ROC compressor and decompressor. So it looks like from the ROC community, we will have to define our own compressor, which is definitely based on the ROC one. And then it's not anymore ROC profile, but that's going to be rules. But basically, that's a difference. So, okay, right. And well, another thing I'd like to mention is that currently we have already some framework to compress the inner packet of the IPsec, of ESP. This is called ROC over IPsec. But it doesn't really work in our case because we are really compressing some fields of ESP. So it should be ROC in ESP. Next slide. Well, we don't touch the crypto. That's I think the key thing. Next slide. Well, it's just to mention where the compression occurs. So it occurs once the ESP packet has been formed. Next slide. So we had a few questions with Tero. Well, we had a presentation on 6 law about IDSP, and then we came with a few questions with Tero. So one of the first question is, do we have padding with ESP? So yes, the answer is we have ESP requires 32 and 64-bit alignment. Maybe we can see next slide. Actually, I only found 32 regarding ESP.
We're out of time.
Yeah, I don't think we need to go to that much detail.
Okay, Rand. So then I think it's only questions and we can discuss that.
Right, and we have the slides on the website as background if anyone needs. So with that, I think that that concludes Ipsecme for IETF 96.
One more thing I want to mention. I2NSF is meeting on Thursday, and they're going to have a presentation on SDN-based IPsec flow protection, which is a kind of a way for the SDN controller to define IPsec tunnels on the on the NSFs that it controls. And I think there are some really bad stuff in that draft. For one thing, it doesn't recognize the fact that IPsec tunnels have to be configured on both sides. It just defines a tunnel on one side. So, and when you come to think of it, there's really nothing anywhere that defines what happens when configuration changes in IPsec. And for a firewall, it's really, well, previously you let this traffic flow, now you drop this traffic. But if you change in midstream from encrypting something to sending it in the clear, you really have to have it synchronized on both sides, and you really have to have some story of what the endpoints do when things change, and those drafts don't have anything about that. So if you want to go there and yell at them, or if you want to read that and comment on whatever list, I2NSF, interface to network security function. And they're meeting on Thursday.
But if I'm correct, that's an old draft from SDN at RG. I think so.
I can run those down. All right, thank you.
So what should we do?
Yes, let's think about that. At the EDDSA, the cryptography stuff. Okay. Yes.